So basically, right, a random sample of 8 pairs of values x and y is used to obtain the following equation of regression line. So this is y on x. This is y on x. And then you were told that this guy is x on y respectively. So the order matters. This case here, 7 of the pairs of the data is given below. So we are told to find the 8 pairs. So you let the 8 pair be AB lah. Correct? Let the 8 pair be AB. Find the 8 pair of the value of x and y. So I'm gonna let, actually you can just let it be, I think let it be AB lah, easier. Now take note you want to solve for A and B. You're given 2 linear regression. What point lies on these 2 equation here? X bar, y bar. So if you were to solve because this is a negative slope, right? The x on y is always steeper. Then this is y on x. Like it looks something like that. They will definitely intersect x bar, y bar. Okay, so you can just solve simultaneous equation. The intercept that you get from these 2 line equation would be the x bar, y bar. So you just solve simultaneous equation. So I just take the line equation, first one, second one, solve it. Okay. Then from GC you find the x bar, y bar. The intercept will be the x bar, y bar. Hence x bar equals to 13. Y bar equals to 6. And you just find all the range, the values that you have. Just find the average. The 8 pair is A, like that. Okay, so the 8 pair will be what? Okay, so this is 8 pair, 8th pair of values of x and y. Determine the product moment correlation coefficient, right? And say that you find the R lah. X on y on x on y, the R value is the same. So basically, they are the same. Okay, so you don't have to worry about it. So this guy, remember just now what I say, that the R value is the same for both y on x and x on y. So just key in calculator, it doesn't matter. Key in with the 10 and 8 in. You need to key that in, the 8 pair, put it in. So here what we get is the stats, right? Edit, just key in, clear it, clear again, then just put in 10, 11, 12 until the last one, which is 10. Key this in, then you go to stats, you just calculate number 4, put L1, L2 inside. So your best to put L1 and L2 here. Just make sure it's L1 is X list and Y list. Calculate, this is your R value. Okay, there you go. This is the product moment correlation coefficient. So this one, say what it leads you to expect about the scatter diagram in this sample. Basically, the scatter diagram, you expect it to be lying close to the best fit line, right? And then like you have a strong linear correlation. So and because it's negatively correlated, is basically as x increases, y decreases. So just write down what do you think about it. Okay. So just write down what you expect to see the scatter diagram to behave like. But you can just go to GC and check the scatter diagram how it looks like also. Here you just zoom stats. Okay. So for this case here, y be the value obtained by substituting a sample value of x into the equation regression line of y equals x. So basically, you just want to, you're using y on x, right? So eyeball this one. So there's a capital Y here. This y value here, you just substitute this 10 into this guy. Then you pick out what's the value here. Okay. Same thing, you take this one, put inside here, you pick out what's the value here. So essentially the y value, you just keep substituting in and then evaluate all these value out. That's all. Okay, evaluate y for each of the value of x. So just evaluate just that's all. So you can key in calculator, bring your GCA. So this one, I'll let it, this is L1, this is L2, this is L3, right? This is L1, L2. The capital Y will be my L3. So L3 is my capital Y. I sub into this equation here. Okay, hear me out. Go to your GC. You go to stats, right? Go to edit. Go to this list here. L3 should be your capital Y. I want to key in this equation here. Okay. So you go to the header, bro. Go to header. You are putting negative 7/10. This value here, you put L1 because you're substituting L1 inside. This is L1. So put L1. L1 is this blue color one. You see this one? So second L1. Then you put plus 151. Then you put 10. Okay. Then you just press enter. There you go. The values all come out here. Okay. These are the, actually I should just put in decimal point. I shouldn't put in this let me just put in decimal point. How do I put in decimal point? You just put negative 0.7. Because the 7 over 10 is 0.7, L1. Okay. Plus 151 divided by 10. I just put at that. I press enter. It'll be in decimal point. Okay. I'm going to copy my answer here of 8.1, 7.4, 6.7. Okay, key this in. Then the next one is evaluating this guy. What is evaluating this guy mean? This is what? This is the verify that this guy is 8.8, right? What you need to do is essentially just take y minus y, you square it, right? Then you just sum everything. Basically, you take this one minus of this one, square it, this one minus of this one, square it, and so on, right? So the idea is just square everything. What I'll do is this one, I'll put L4. My L4 is small y minus capital Y square. Okay. So meaning this guy is L2 minus L3 square. That's what I'm going to do. Then I'm going to sum them up. Okay. So from GC, right? You can manually calculate, or you can just use GC. You just put L2, which is L2 with Y value, L2, minus of L3, right? Then you square it. Press enter. These are the values here. L4 is what you want to sum, right? Just understand, you go to stats, right? You calculate one variable stats, you put L4. Okay. And then the L4 here, this summation of x will be 8.8. So this will be 8.8 lah. So this will be 8.8. Verified. Okay, the last part is the one which will separate the A student and the B student, or rather like the A and more A student, A and A star student. For each of the A sample value of x, right, bar y is given by this one, A plus bx. So essentially, A and B are any constants lah. Okay, what can you say about y minus y bar, y prime square? So just this one, basically this guy here, y minus y is what? Okay, so if you think about it, right, y minus y, this is on the line of best fit. This is line of best fit, right? This is a data point. Okay, if you think about it, I'm going to plot the line equation here. I'm going to store the regression equation here, alpha f41. Then I put this as L1, L2, graph it. How come it's not there? You know, number 4. So I key in the y equals x line here. This is the graph here. Understand this, this bar y minus y, this value here is y. This is a small y, then this is the bar y. The bar y is on the line of best fit. Okay. So when you take this one, this is the sum of squares, the error, and this is the least square. Essentially, what you're doing is you take to this point here, you find the least square here. This one least square, this one here. These are the errors, okay? And these are the sum of least squares. Because it's a least square, you will expect y minus y prime. Any other values will definitely be more than 8.8, okay? Because this is already the least square already, okay? Basically, what I'm saying is any value, this is another line equation. It doesn't matter. This is the best line of best fit to this whatever line is represented, right? This value to the line of best fit definitely will be bigger than 8.8. Confirm one. Okay, that's the idea. I just add this sentence. The regression line minimizes this guy. Okay, so since this is the sum of least square for the data set, so this would, whatever line to the best fit would definitely be bigger than 8.8.